Hey, Mr. H, back with you again. We are taking a peek as we get some more light on the situation here at logarithmic and exponential form. So we've taken a look at exponentials here, and now we're going to start dealing with something with logarithms. So common versus a natural logarithm. This is mainly going to be, like something like log of x. Now, you're like, okay, what's this log thing? Is it like, like the wood or something? No, it's another way. Logarithms are used a lot in like electronics, okay? It has to do with like the sound waves or your cable waves or your cell phone waves and things like that. So it comes into play a lot there. But our common log is just going to be log of x. And normally there's going to be a little number down here, okay? If we don't see a little number down there, which is called the base of our log, we assume it's 10. Sorry, my 1 and my 0 look kind of cursive there. But that can be any value, and we're going to get it into a generic form here in a minute. Our natural log is just ln x, and there's not a huge difference as far as what we're going to be doing with these, but I want you to be aware of the terminology, okay? So log versus natural log. So what are these forms? What do they look like, and how do we use them for mathematical purposes? So if something's in logarithmic form, now don't worry, we're going to have numbers in most of these places. It's not going to be all these variables. But here's the easiest way I can explain this, again, kind of using English like we have before, okay? B stands for your base. Now, base, again, is something like we did before with exponents. So if you had 4 to the second power, 4 was your base that you're working with. And it's going to come back into play here because, as you can see, we're going to be having exponentials here shortly as well. Still looking for my colors here. All right. Then, now again, this is me using layman's terms, not the mathematical terms here that we've got as far as these go. A is going to take on the same job as our exponent normally would. Now that's going to seem strange. You're like, A is not an exponent. It's like over here on the other side by itself. What are you talking about? Stick with me for a minute. I'm going to show you where this is coming from. Okay. And then N is somewhat equivalent to our answer. So what are you trying to get to, Hardy? Let me show you. So for example, if I have log base 416 equals 2. Okay, think about that for a second. If 4 was my base and 2 is my exponent, what's 4 squared? 16. You're like, seriously? Yeah. And there's another way I can show you how that works. I normally don't show this right away, but I'm going to show it here. Well, actually, I've got it on my calculator. There it is. It just popped up. If you take the log of the bigger number and divide it by the log of the little base number, okay? So log of 16 divided by log 4, look what you get. You get 2. So these logs and exponentials have this relationship that gets used this way, but it's mainly having to get used to what the form looks like, okay? And we're going to do that a lot during this lesson to get you rolling with that. Now, let's follow that up with the exponential forms. Okay, so this is my base logarithmic form, okay? My base exponential form would be b to the a equals n. That's what we've seen forever. So if I take those same values from my example over here, and I take my example, I'm like 4 to the second power equals 16. These two things are equivalent to each other going from logarithm to exponent or exponent to logarithm, okay? Because notice everything's still in the same places. That's still my base, okay? A is still my exponent of sorts, and that's still my answer. So we've just got to get used to going back and forth with these. And that's the biggest challenge, but we also are going to have this to use as we need it before we get there. So in this next level down, we're going to work on going from logarithmic to exponential and back and forth, okay? So here with my log, And again, maybe you want to label everything as you start. I don't know. But here's what I do. I always say little number is always my base. Okay. The equals number is always my exponent. And whatever's here is always my answer. So yeah, 4 to the 16th power, that's way big of a number. So we could just leave it. But that's it. These two get me the same answer if I had the opportunity to be able to calculate them. You're like, well, then what do I do with natural log? How does that work? Now this one gets a little bit trickier. And I'm trying to figure out where my... All right. Excuse me for the delay there. That was, yeah, had a little bit of a, I'll say it, brain fart there. So we're a little bit not far enough ahead to be doing this. So we're going to leave that for now. We may come back there. We may not. So our main thing here when we're looking at something as an exponential then, okay, to get back here, we're going to avoid this. We're sticking to logs on this. Just with the way the year's been going, we need to keep life simple sometimes. So here what I would suggest doing, if you're not comfortable with going back and forth, is that you label the different pieces. So here B would be 5, A would be X, N would be Y. And so then you can just kind of follow here and go log B. And you look at it and you're like, oh, 5 to the X power equals Y. Base, exponent, answer. 5 to the X power equals Y. Okay, and it kind of makes more sense that way. So that's how we're going to kind of invert back and forth here. So here you're like, oh, how's that work? Again, my B would be 10, my A would be 3, and my N would be X plus 1. So log base, okay. Now what would be next? Base, exponent, answer. 10 to the third equals X plus 1. Okay. That's what I want you to lock in on right now. We will deal with some natural log stuff with inverses, but I don't want you to be driving yourself crazy. This is a new enough thing as it is. So until you start feeling more comfortable just kind of counting your way along, and we'll see some more of these to do that, just keep this handy where you can just plug the numbers in and label them. Okay, now we're going to hit reality. Evaluating logarithmic expressions without a calculator. Now, I'm going to show you how to do it without a calculator, but then I'm going to show you what the reality is of what everybody's probably going to do. So here's what we're going to do. With these, I'm going to put an equals X on them for these first couple, because here's what we're going to do. We're going to put it into an exponential form. We're going to say, hey, 3 to what power equals 81? Now, maybe you know that off the top of your head. That'd be cool if you did. If not, we just kind of play with numbers. Like 3? No. 4? Yep. Okay. My answer is 4. Or I come here and I'm like, okay, 5 to what power equals 1? You're like, wait a minute. 5 is bigger than 1. Now let's think to our rules for a minute, though. Anything to what specific power is always 1? 0. Now let's do reality, because you're going to find this out anyway. So I always just tell you right away. You also, if you can't figure out what the X is sometime, you have another option, which is called change of base. Okay, change of base is when you take the log of the big divided by the log of the little. Okay, log of my N divided by log of my B. And if you type that in your calculator, log 81, don't forget to close your parenthesis, divided by log 3, you get the same answer. You're like, wait, does that work every time? Let's test it out. Big divided by log little. And you're like, wait a minute, 5 is bigger than 1. Physical size. Log of N divided by log of B. Let's see what we get. Log of 1 divided by log of 5. 0. So you're like, that works on all of these. Yep. The question is, do you really need it on all of them? 4 to the x power equals 4. Do you really need to change base on that? Really? 4 to what power is 4? 1. Okay, we don't need it for that. Maybe over here, though. Like, wait. 1/2 to what power equals 8? You really think I could figure this out, Hardy? And the answer is yes, and here's why. I'll still show you change of base, and some of you may have done it already. Forget about the 1 being here for a minute. 2 to what power equals 8? Because it's a perfect cube. 2 cubed, 2 to the 3rd power. So you're like, okay, so it would be 3. But that would be 2 to the x equals 8 would be 2 to the 3rd, okay? But I don't want it as 2, it's 1/2. What do you have to do to 1/2 to make it 2? Flip it. What exponent rule do we use to make things flip? We use negative exponents. Is 1/2 to the negative 3rd 8? It is. So whenever you run into this, don't freak because it's a fraction. Just look at it as a whole number and say, hey, can I figure out 2 to what power equals 8 or 3 to what power equals 9 or 27? And if you can, you just put the negative on it later, okay? Now, could you still do log 8 divided by log 1/2 and get the answer? Sure can. Options. I love giving you options. Okay. Otherwise, we can just use the technology. If you just get something like this, I mean, you don't have multiple numbers, it's just log 5, then just type in log 5. You're going to get decimals, 0.699. A lot of times we go to the nearest thousandth, but you got to watch, there might be different options there. And then if you're asked for the natural log, it's right below log. Okay. Does it matter which one I use? It can. So you kind of want to follow along with which one it is. You can't use log and natural log, back and forth there. Something to keep in mind. Okay, I'm going past the science connection for right now. I want to keep life simple today as we're looking at these. Okay, so inverses. Okay. What this is basically telling you is that a log's base, okay, and its end value here, if they're right next to each other, it's almost like they cancel out and just leave you with the exponent. Or if you have the base and then you have the log of that base up here, still, it's like they're inverses. That's what inverses do. They cancel each other out. They're opposites. So if you ever see something like this where you have log base 6, 6 cubed, the 6 and the 6 cancel and just leave me with 3. Because, let's say I went to my calculator. What's 6 to the 3rd? Is 216. So it'd be log 216 divided by log 6. 3. Okay, I still have options. 5 and log 5, cancel. Leave me with x. Okay, the one we haven't chatted about yet, okay, for inverse properties is e and natural log, or natural log of e. Okay, e, we've talked about that number before, like 2.71, and natural log are opposites. They cancel each other out when they're next to each other. So when I see this, okay, typing that into my calculator isn't going to help me. I've got to know that they're inverses. Here, ln times e makes this 5 times 2, not 5 squared. That squared was on the e, and the e went away, so the 2 just drops down. Could I type that into my calculator? I could, actually. Okay, if you wanted to type that into your calculator because you weren't sure, e is second in natural log. I get the answer. And then the last reminder, we didn't do this since the front. If you have a regular log, remember, that's assumed that that base number is 10 if you don't see one. So if you don't see one and you cancel those out, you get the 2. But again, could you type it in your calculator? Sure could. So finding inverses. We were kind of chatting about it up above. You're going to use the base number as your inverse. So when you get a question here like, y equals log 3 to the x. Now remember, we're still finding an inverse, so you still need to switch x and y and solve for y. Switch x and y. And since I'm solving for y, what do I have to do? I have to get rid of log base 3. You cannot divide it out, okay? The only way you can get rid of it is by what's called exponentiating, which means we're going to use this base 3 and turn both sides into an exponent. Again, I know it's weird, especially at the start. Those cancel. 3 to the x power equals y, not 3 times x. 3 to the x power, and that's going to be true each time. So if you have that here, again, remember, if I don't see a number, it's 10. Switch x and y. And solve for y by using the base. 10 to the x equals y. So you're like, whenever it's a log, is x going to end up in the exponent? Yes, it is. And then with exponential functions, okay, let's see. X equals 4 to the y. How do I get rid of the 4? Come back down. I use the log of that base. So here, I'm going to use log base 4. Got to do it to both sides. This is still algebra. Whatever we do to one side, we do to both. So you start to notice something. You're like, wait a minute. So when I do the inverse of a log, it ends up as an exponential. X is in the exponent, right? And when I do the inverse of an exponential, okay, I'm still going to use the base number as my inverse most of the time. Well, actually, use the log of the base number as my inverse. So here, I end up with a logarithm. Start with an exponent, end up with a log. X equals e to the y. Remember what the inverse of e is? Natural log. So we can end up with natural log or log in our solution sets when we do these. Now, let's see here. Trying to see if there's anything on that worksheet that looks like it would be crazy compared to what we did. It actually does not. It's pretty straightforward. The worksheet that you're going to be looking at with this is 7.3a. And it runs almost parallel to the note sheet with the examples. So I'll say what I always do. This one's a little bigger of a worksheet. I would just do the evens, check my answers, and then if they're right, great. You're probably ready to just do the online stuff. If not, try some of the odds or shoot a question to me. Shoot me a picture of what you wrote, and then I can kind of start to help figure out what's going on. But keep at it. More logs coming next time, and we'll see you then.